Okay, we're looking at one of the algebraic methods for solving a system of equations. It's called the method of substitution. So you've done the graphical method and done it by hand and with a calculator. Now the system, solving a system by substitution and elimination are the algebraic methods so that you end up getting an exact solution. Sometimes when you graph by hand, you can't tell exactly what it is. Calculator just gives you a decimal version. Okay, so it's really what it sounds like. You're going to substitute one of the equations into the other. Because remember, you do have a graph of two lines that intersect. The x values have to be the same and the y values have to be the same. So this y here has to be the same as this one. This x has to be the same as this. So here are two equations. Call that equation 1 and equation 2. In this case, equation 2 is already solved for one of the variables. It's solved for y. This is in slope y-intercept form. This one's really not in any particular form, but this one's solved for y, so we're going to substitute the second equation into the first one. Sometimes it'll be the first into the second, but no matter what, you have to get y by itself or x by itself, or whatever variables there are. So now we're going to, basically what I do is I write out the coefficients. I put brackets where I'm going to do my substitution. And then I'm going to switch to red here. And so my equation 2 says y equals 3x minus 1. So that's what I'm going to substitute in. So now you'll notice that your equation is only in terms of x. So when we expand, we collect like terms, and we solve for x. Okay, so x equals 2. You might think, oh, I'm done. But remember, it's a point, right? A solution to a system has an x value and a y value. So now we're going to substitute x equals 2 into one of the two equations. I'm going to put it into the second equation. So y equals 3 times the x value minus 1. X value is 2. So that's going to be 6 minus 1 is 5. So you can write it as an ordered pair. So the x value is 2, the y value is 5, and that's your solution set. Okay, if these were different letters used for the variables, I'd probably do just a statement together, or you could write this together rather than in the work. Just make it clear what your solution is. To verify, we'll start with the equation 1. So that's 2y minus x equals 8. So now this will be 2 times, so the point here is 2, 5. So 2 times 5 minus 2. Well, that's 10 minus 2, which is 8. So left side equals right side. Then the second equation, you always have to check into both. So y is 5. 3 times 2 minus 1 is 5, right? So left side equals right side. So that verifies. You always have to check your point into both lines. Okay, let's look at the next one. So again, these aren't in any type of particular form of an equation, but we're asked to use substitution. So remember, we want to have x equals or y equals. Now looking at the first one, I'm not going to solve that for either x or y because I'd have fractions, because there's coefficients in front of both terms. This one though, that's just minus 1x. So I'm going to solve this equation. I'm going to solve for x. So what happens when I do that? I would have negative x equals 9 minus 3y. Again, order of the terms doesn't matter, because this is just to do our work. Then divide both by negative 1. So negative 9 plus 3y. Or you could show that as x equals 3y minus 9. So now we're going to substitute that into equation 1. This is 1, this is 2. So it's going to be 3y plus 2 times the expression for x minus 18 equals 0. I'm going to put that in red. Okay, and then expand out. And that's going to be 9y minus 36 equals 0. So 9y equals 36. So y equals 4. And then you can take that and substitute it into equation 2. You can use the rearranged version. Now saying that, if you rearranged incorrectly, then you're sort of compounding your error. Okay, so that's going to be 12 minus 9 is 3. Okay, so you can summarize, as I said, x equals 3, y equals 4, or you can show it as an ordered pair. And that's your set of solutions. Okay. Next one, neither of these have coefficients that are 1. So a little bit harder to do. We're actually going to learn another algebraic method called elimination, which will be useful for these types of systems. My choice in this one, though, would be, at least with this, there's no constant term. So it's a little bit easier. They'd only have one fraction. This you'd have 2. Well, I guess if you solve for x, you might not. But in any case, I would do this. I'm going to solve for y, just because we're used to solving for y. Okay, and then I'm going to substitute that into equation 1. Now, it just so happens that I've been taking equation 2 and substituting into equation 1 in these examples, but it doesn't, that's not a rule. You can do equation 1 into equation 2, whichever is easiest. Okay, so in this one, we're going to have 2x plus 3 times this expression for y. So that's negative 6/5 x. Okay, so then expand out the brackets. Okay, and now you could collect like terms. I would actually multiply through by 5 to get rid of the fractions. But again, it's kind of your preference. So if I do that, I get 10x minus 18x equals negative 20. So that's negative 8x equals negative 20. So x equals negative 20 over negative 8, which reduces to positive 5 over 2. And then we can take that and to get y, so substitute into equation 2. So we've solved for y, so negative 6/5 times 5 over 2. And notice how the 5's divide out and 2 goes into 6 3 times, so it's negative 3. Okay, so again, you could rewrite your solutions, okay, and put a box around them, or you can state it as a set of ordered pairs. Okay, but that's it, right? And it did say to verify for questions A, F, and H. So we're on C, so we're safe so far. Okay, next one. This one's already solved for y, so I would again take this equation and substitute it. So substitute 2 into 1. Now saying it's got a fraction, really, when we have a choice of what method, you might actually want to expand this back out and use elimination. But it's already solved for y. So 3x plus 5 times the expression for y equals 10. So that's negative 3/5 x plus 7. So that's minus 3x plus 35 equals 10. And what happens? You get 35. This goes to 0. You get 35 equals 10. Well, that can never happen, right? 35 is very different from 10. So this one has no solutions. So when you think about what it would look like, we talked about this in when we were solving by graphing. If it has no solutions, it has to be parallel and distinct. So that means same slopes, but different y-intercepts. So take a look. There's the slope negative 3/5. If we solve this one, we get 5y equals negative 3x plus 10. Y equals negative 3/5 x plus 2. So, yep, same slope, but different y-intercepts. So that confirms it. Okay. Next one, not solved completely for y. This one has a coefficient of 1. So I'm actually going to solve this one for x. Okay, so that's going to be negative x equals 12 minus 4y. And so x equals negative 12 plus 4y, which you could also show as 4y minus 12. In any case, we're going to substitute into equation 2. Right? This was 1, that's 2. So we'll have 2y equals 1/2 bracket plus 6. And so we have 4y minus 12 in the bracket. So 2y equals, multiply through by half, is 2y minus 6 plus 6. Well, what happens here? That goes to 0. You get 2y equals 2y. Well, yeah, if y is the same number, which it has to be, those are always true. If you brought that over, you'd get 0 equals 0. Okay, no matter what. If the left side equals the right side, there's infinitely many solutions. Okay, so what is the solution? You rewrite one of them. So the solution is, I'm just going to rewrite 4y minus x equals 12. Okay, you just rewrite one of the equations. And if we take a look back here, if we looked at the slope, well, this, if we solve for y here, we would get x over 4, or 1/4 x. So slope is 1/4. Here we divide by 2, so we get slope equals 1/4. So you know that they're parallel. And then when we divide this by 4, we get 3. When we divide 6 by 2, we get 3. So the same y-intercept. So equal slopes, same y-intercept. Okay, and so we call these parallel and coincident lines. Co means together, incident means they run into each other. So co all the way along the line. So infinitely many points of intersection. Okay, so now question F is a linear and a quadratic. So we're going to solve those systems. This one's, well, both of them are already solved for a variable. So totally up to you what you want to do. If you want to substitute the y into the second one or the x into the first one, I'll maybe do substitute 1 into 2. just because if I went 2 into 1, you're going to have to square a binomial. Okay, and sometimes students go wrong on that. We'll probably do it both ways just so you can see. So we're going to have x equals y minus 2, and where y, I put x squared plus 2. So I have x equals x squared plus 2 minus 2, so x equals x squared, and then don't divide by x, never divide by x, so we're going to want to bring x to the right and then factor it. It's a common factor. So our solutions here are 0 and 1. Now for what we call a linear quadratic system, we have to find the y value for each of these. So if x equals 0, then y equals 0 squared plus 2, which is 2. If x equals 1, then y equals 1 squared plus 2, which is 3. So you'll have 2 points here, okay? Because a quadratic is really U-shaped, okay? And then a line going through. You'll have 2 points. In this case, doesn't always happen. But for an x value of 0, we got a y value of 2. For an x value of 1, we got a y value of 3. So we actually have 2 points. All right, now, if you had done the other way, 2 into 1, then we would have y equals, you would replace x with y minus 2. Okay, and then you'd have to expand correctly. So remember that's minus 4y plus 4. Don't forget that middle term. Then you'd want one side equaling 0. What did I just, yeah. So then minus 4y minus y is minus 5y plus 6. And then factor that. So y minus 3, y minus 2. So y equals 3 or 2. Notice how that's what we had there. Okay, so this is the OR method, the optional. Okay, in terms of verifying, yikes, that wasn't very straight. So take your first equation, and we have to check for both points. So first equation, the y value is 2. The x is 0, so 2 equals 2. So that works. And then we check into the other equation. So the x is 0, and the y is 2. So that works. So this point is good. Now the other point's 1, 3. So 3 for y, 1 for x. And that gives you 3. Left side equals right side. Then x, y minus 2. So your x is 1, your y is 3. Left side equals right side. Okay, we verified. All right, now we have a linear and a cubic. Again, they're both solved for y, so really it doesn't matter. So how about, rather than, I'm going to put 1 into 2. Really doesn't matter. Okay, so that means I'm going to replace the y on the left. Oops, I'll do it in red. Okay, so into equation 2 means we'll have 4x on the right. And so we're substituting x cubed in. Okay, so now again, don't want to divide by x because you eliminate a solution. So we're going to bring the 4x to the left. Anytime it's greater than degree 1, you want to get one side equaling 0. Now we can factor that. It's going to be x squared minus 4 when we factor out an x, and we can factor that out, factor again. That's a difference of squares. So now we have when x equals, oh yeah, we have to solve it here, sorry. So solving it, x equals 0, -2, and +2. So when x equals 0, then you want to substitute in either of these equations. So I'll do into equation 2. So then we'd have y equals 4 times 0, which is 0. And then x equals 0, x equals -2 into that equation. So y equals 4 times -2 is -8, and x equals +2 into that equation. That would be y equals 4 times 2, which is +8. So this solution is 0, 0. This is -2, -8, and this is 2, +8. So 3 possible solutions there. Now have a system of 3 equations in 3 unknowns. So in order to solve this, we're still going to kind of use the same method of substitution, but we need to get this down into 2 equations in 2 unknowns. So we're going to take sort of pairs, maybe the first and the second together, and the first and the third, or you could do first and second, second and third. But you want to substitute, say, the first one into the second to get rid of one of the variables, okay? And then do the same thing into the other. If you go on to Math 35, you're going to be doing more of this and learning more methods for doing this. Well, I guess maybe not a whole lot more methods, but a little bit. In any case, let's call this equation 1, 2, and 3. I'm going to take equation 1 and solve for b. Either that or equation 3, okay? But b here I can get by itself, so that'll be 14 minus 5a plus c. And then I'm going to substitute, so substitute 1 into 2. So that'll be 2a minus 3b, which is 14 minus 5a plus c, minus 7c equals 2. It's going to be minus 42 plus 15a minus 3c minus 7c equals 2. 17a minus 10c, bring the 42 over, is 44. Then I'm going to take same original equation and put it into the other one. So then I'm going to have a plus brackets 14 minus 5a plus c equals 4. So a plus 14 minus 5a plus c equals 4. It's going to be negative 4a plus 2c equals negative 10. And I'd actually divide everything by negative 2. Just to, it's a common factor to everything, and I like having the a term positive. Okay, now that's my, oops, that should be 2a. That's my new system. Okay, I'm going to call this equation A, and this is B. So now I'm going to take B. I can solve for C easily here. It's 2a minus 5, and I'm going to substitute B into A. So that'll be 17, oops, 17a minus 10, C is 2a minus 5 equals 44. 17a minus 20a, oops, 20a plus 50 equals 44. So negative 3a equals negative 6, so a equals 2. Then substitute that back into B. So C will be 2 times 2 minus 5, which is negative 1. And then you have to put both of these into one of the original equations. So I'm going to go back to equation 1 because I had already solved for b. So b was 14 minus 5 times a. What was it again? Sorry, 14 minus 5 times a plus c. 14 minus 10 minus 1 is 3. So a is 2, b is 3, c is -1. So that's what I'm going to verify up here. So my first equation, 5a plus b minus c is 14. So, and my values, you can show it as an ordered pair, 2, 3, -1. So 5 times 2 plus 3 minus -1. 10 plus 3 plus 1 is 14. Okay, that works. Into the next one, that's 2a minus 3b minus 7c equals 2. So 2 times 2 minus 3 times 3 minus 7 times -1 is 2. And then the last one is a plus b plus c is 4. So that's 2 plus 3 plus -1 is 4. Okay, so it's verified. And we are done.